when you take a cone and slice it by a plane. So one of the conic sections we've done in a previous video, and that is a parabola. And if you looked at parabolas in your algebra classes, they only talk pretty much about the axis of symmetry and the vertex, and whether the parabola is up or down and stretches that occur on it. But really there's also that concept of the focus of a parabola that has a lot of applications in everyday life. So to see that, I've connected the link to the video on parabolas in this description. Now, other curves that you can get from slicing a cone from a plane: an ellipse, a circle, and a hyperbola, and then again the parabola. So there are four. And those four curves make up what are called the conic sections. In this video we're going to look at the conic section, the ellipse. Now with an ellipse, it has the characteristic that it's the locus of all points that have sum of the distances from the focus to a point on the ellipse and the distance from the other focus to the point on the ellipse. That sum of those two distances is the same throughout the entire ellipse. Now if you wanted to make an ellipse, what you could do is make your horizontal and vertical axis and then measure the same distance away from the center to these push points that you put in, and then cut a piece of string that is a longer piece of string than the distance between the push points. So this piece of string is that sum of the distances between the focus to the point and then from the point on the curve to the other focus. Now if then you take your pencil or pen and hold it so the string is taut and just pull it around, and then when you get to this other side you would flip it over and do the same thing, then that curve you get is an ellipse. Now these push pins are at what are called the foci of the ellipse. The place that your horizontal and vertical axes meet is the center. And the distance from the center to the focus is a distance called C. So they denote that C throughout with the ellipse. These further out points that are on the same axis as the foci, those are called the vertices. And the distance from the center to the vertex is A. And then from the center to what are called the co-vertex, they're not on the same axis as the foci and the vertices. That's the value B. So those are the components of an ellipse that we are also going to look at in the diagrams that I drew on the board. When I look at an ellipse, the length of the major axis, that's your longer axis that the vertices and the foci are on, that length is 2 times A. So A is from the center out to the vertex. So if you do another A to the other vertex, the total length of that major axis is 2A. The length of the minor axis, so that's from the center to the co-vertices, that's going to be 2B. And then an area of an ellipse, we actually have a formula for the area of an ellipse, and it's A times B times pi, so AB pi. Now, if my major axis is horizontal, so that's the one that I did the way that I held the board up when I was going through and doing the process. So if it's horizontal, it's longer than it's tall. And so along the horizontal axis is from the center going C distance either way will get you to the focus. And then from the center of the ellipse going A amount either way will take you to the vertices. Now from the center going B up and down are going to get you to your co-vertices. The equation for an ellipse is x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1 if I have the horizontal axis. That is my major axis. And if I just took and set it up here and make it go vertical like this for your major axis, then you have the same components of it. It's just sitting where it's taller than it is y. And notice here, the equation is x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. Well, when there's a plus in between, it's going to be up to us to recognize which of our denominators is our a squared and which of our denominators is our b squared. Once we've got everything rearranged, one's on the right-hand side, and I have just coefficients of 1 in the numerators of these. And with an ellipse, your a squared is always your bigger denominator. So you identify a squared is the bigger denominator for an ellipse. Now, what I did with making the diagram is what I've already listed up here. And again, your center is, we denote it HK. The distance from that center, HK, to the foci is your C value either way off of that HK. Your vertices starts at the center HK and goes a distance either way to get to the vertices. And then for your co-vertices, it's your center HK and go B up and down off of it to get to your co-vertices. So depending on like which orientation you have on your ellipse will actually determine whether you're taking that C value or the A value or the B value and adding it or subtracting it off of the X coordinate or the Y coordinate. But you just want to draw these out as much as you can and think about it. So if I have my center HK and I want to get to the foci, which is also on a horizontal line with that, then it's my X coordinate that's changing, not my Y. So then I'll have the H minus C comma K for that one and H plus C comma K for that one. And then again going to the vertices, it would be H minus A for this vertex comma K and then H plus A comma K for this vertex. But to get the co-vertices, my up-down is changing, not my left-right. So then my H stays the same, but the K changes. So H comma K plus B is the top one, and H comma K minus B is the bottom one. So if you think about that and just kind of like put yourself back into, well, what makes sense that it would change, it makes this concept so much easier because you're not trying to like think of all of those different formulas. You just got the basic one and then you are seeing what needs to change and how to find the values from there. And then for the vertical, my center is HK. So to get to the foci on the vertical axis, my Y coordinate of my center will be affected. So this will be H comma K plus C. This will be H comma K minus C. And then for the vertices, H comma K plus A, then H comma K minus A. And then your co-vertices, H minus B comma K, H plus B comma K. Now, another thing is that when I have information, I'm not really sure which two of the three things I'll know. If I have the equation and I go and rearrange it, I'll get my A squared and my B squared, but not my C squared yet. If I have someone telling me some different pieces about an ellipse and they give me information about the vertex and the foci, I'll get my A and C first, but not know what my B is. Well, the connection between your A, B, and C for an ellipse is that B squared is equal to A squared minus C squared. So if I just have two of the three of those things and I need to find the other one, I come to this relationship that B squared is equal to A squared minus C squared, and I can find the missing one that I need. Also, when you're looking at our idea of an ellipse, there's something called an eccentricity. And the eccentricity of it will help us determine kind of the shape that that ellipse has. You find your eccentricity from the C value divided by the A value. Now for an ellipse, your eccentricity is always between 0 and 1, not including the endpoints. And the closer that the eccentricity is to 0, the more circular your ellipse will be. And the closer your eccentricity is to 1, the more elongated it will be, whether it's horizontal or whether it's vertical. So now that we have all of this background information presented, let's go ahead and look at, for our first example, they're giving us an equation and they want us to find the center, the vertices, the foci, and the eccentricity of this equation. Now, when I look at this, as long as it's not a degenerate case, as long as it's something that actually is a curve that can occur, when the squared terms are on both the x and the y, and the coefficients have the same sign, so they're either both positive or they're both negative, but different numbers from each other, this is a 4, that's a 1, that's when you have the possibility of having an ellipse if you have a curve. So both variables squared, sign is the same, coefficients are different, that's an ellipse. Now, in order to figure out what my center, vertices, foci, and eccentricity are, I need to take this equation and transform it into either of these two forms. And to do that, notice I have binomial quantity squareds, and this is all multiplied out. So what I'm going to have to do is to complete the square on this in order to find out what those values are. We're going to first rewrite it by getting the x variable terms together, leave a space for completing the square, and then the y variable terms next to each other, leave a space for completing the square, equal to, and we're going to add that constant over to the other side. Now, when I'm completing the square on this, I know I have to have a coefficient of 1 in front of my squared term in order to complete the square. And in my first one, I have a 4x squared. So just out of the x's here, I'm going to factor out that common factor of 4. And then close my parenthesis for that grouping that I'm going to complete the square, bring down the plus, and then my coefficient in front of my y squared is already a 1, so I don't need to do a factorization for that part. Now, when I complete the square, remember, you take 1/2 the middle coefficient that's in the parentheses after you factored out that common factor. So 1/2 of -2 is -1. Square that -1 is +1. And that's what you add in the parentheses to complete the square on this trinomial that's in the parentheses. Now, you didn't change this left side by 1 though. When you put a 1 in a parentheses that is affected by a multiplication of 4 outside, what you really did was affected that side by 4, because 4 times the 1 you put in there is going to give me a 4 if I were to get rid of the parentheses. So I changed this left side by a +4, so I need to be fair and change the right side by a +4 also. In the y's to complete the square, 1/2 of 4 is 2, and I'll write it right up in here. 1/2 of 4 is 2, and then 2 squared is 4. So I need to add a 4 here to complete the square on the y's, and there wasn't a parenthesis with a constant outside, so 4 is how I affected that side by adding a 4, so I need to add another 4 for the y's. And then factor this perfect square trinomial as binomial quantity squared. Like, what binomial times itself would, if you multiplied it out, would give you this back? Well, when you're looking at these, which is really helpful in terms of working it out, especially if you have fractions or something, is whatever 1/2 the middle was, making sure you took the sign with it when you did half the middle, that's always the number that goes in the binomial factorization when you did the completing the square process. So this factors as x minus 1 quantity squared. plus the factorization of y squared plus 4y plus 4. That factors as y plus 2, half the middle, quantity squared. And then on the right-hand side, I have 8 plus 4 is 12 plus 4 is 16. Now, I need to get a 1 on that right-hand side to be able to sort out what a squared and b squared are. So I need to divide everything through by 16. And I also need to make sure that I have a coefficient of 1 in front of my parentheses in the numerator. So I, in this one, fortunately have a common factor of 4 that we'll remove with that denominator so that I will have a 1 up there. If you didn't, you would flip it back down as a fractional value in the denominator for what's sitting down in the denominator. But here the 4 goes into 16 4 times, and I get x minus 1 quantity squared over 4 plus y plus 2 quantity squared over 16 is equal to 1. So now I have it in that form. And with an ellipse, you look at the two fractions, and the bigger denominator is your a squared. So in this case, a squared is equal to 16, and the smaller of the denominators is your b squared. So b squared is equal to 4. So this bigger denominator is underneath the y letter, so that's going to mean that it is a vertical major axis when the bigger number is under the y letter. That's when you have your vertical major axis. And also my c, remember that b squared is equal to a squared minus c squared for an ellipse. So b squared is 4 is equal to 16 for my a squared minus c squared. If I add a c squared to both sides and subtract a 4, c squared is equal to 12. And then take the square root of both sides, I have that my c is equal to plus or minus the square root of 12, which is 2 times the square root of 3. So this is a major axis, is vertical. So now we are ready to get the value. So I'm going to graphing this out. I have right 1 down 2. So 1 comma negative 2, that's my center. And I know that my major axis runs vertical from the 16 being underneath, the bigger number being underneath the y. All right, now for my vertices, my vertices are a distance away from the center on the major axis. So what we're going to do is from our center of 1 comma negative 2, our a is 4, and really you can think of that as plus or minus 4 to go up 4 off of it to get to the top vertex and subtract the 4 off to get to the bottom. All right, so if I look at from this 1 comma negative 2 going up 4, I need to add 4 to the y coordinate of it. So it'll be 1 comma negative 2 plus 4 is positive 2. And then subtract 4. Negative 2 minus 4 is negative 6 for my y coordinate, so it's 1 comma negative 6. So I have 1, 2, as well as 1 comma negative 6. Now for the foci, they are the c distance away from the center, still on that major axis. So that will be added and subtracted y coordinate of your center. So when I think about adding a 2 square roots of 3 to the y coordinate, well, square root of 3 is about 1.732 multiply that by 2, I get about 3.4. So if I'm adding 3.462 to negative 2, I'm going to get a little bit above 1 on that. So my foci is 1 comma, and I'm just going to write it as negative 2 plus 2 square root of 3. And then for this one, it's 1 comma negative 2 minus 2 square root of 3 for the foci. And then the eccentricity is C over A. So for this example, our eccentricity is 2 square roots of 3 over 4. Which will simplify to the square root of 3 over 2. So just to kind of get all the information in one place, the center is at 1, negative 2. The vertices are at 1, 2, and 1, negative 6. The foci are at 1, comma, negative 2 plus 2 square roots of 3. And 1 comma negative 2 minus 2 square roots of 3. And then my eccentricity is the square root of 3 over 2. Now let's look at an example where they give us the information about the ellipse and we're supposed to come up with the equation for it. Here it says, find the equation of the ellipse with foci at negative 5, negative 1, and 3, negative 1. Vertices at negative 7, negative 1, and 5, negative 1. So if I just kind of get a brief look at what I have, so negative 5, negative 1, and 3, negative 1, then my vertices at negative 7, negative 1, so negative 7, negative 1, and at 5, negative 1. I see that my major axis is running horizontal. So I know it's going to be the x minus h quantity squared over a squared plus the y minus k quantity squared over b squared is equal to 1. Now, I don't know h and k, I don't know a or b, but remember that your center of your ellipse is exactly halfway between the foci, it's halfway between the vertices. So it's actually the midpoint of the line segment connecting either the foci or the vertices. So when you think about doing that midpoint, whether you do the pair of foci to get the midpoint or whether you do the pair of vertices to get the midpoint, you'll get the same midpoint. So here when I want to find what the center is, remember the midpoint of a line segment connecting 2 points, you just average the x's for the x coordinate and you average the y's for the y coordinate. So I'm just going to do it with the foci. So add the two x's together and divide by 2. So it's negative 5 plus 3 over 2. And add the y's together and divide by 2. Negative 1 plus negative 1 divided by 2. So that gives me negative 2 divided by 2 is negative 1, and negative 2 divided by 2 is negative 1. So my center is at negative 1, negative 1. And I just want to kind of put that on my picture just so I can visualize and see if it's like on the right track. But yeah, that's halfway between these points. It's halfway between those points. So now I know my h and k. I know my h is negative 1. I know my k is negative 1. So for that center. All right, next up, I know that the distance from the center to the foci is c. So here, c, I can even count on my grid. So it's 1, 2, 3, 4 away. So c is 4. If I didn't want to count on my grid, I could see that if I take like this x coordinate of the foci, since I know that my horizontal is the major axis is running horizontal, so it's the x coordinates that are changing, the y coordinates staying the same. Well, 3 minus a negative 1 is a distance of 4 away. Then for my A, that's the distance between the vertex and the center for the span of it. So then again, it's my x coordinates that are changing. So if I take this x coordinate 5 and subtract the x coordinate of the center, 5 subtract negative 1 is 6. And again, you could have also counted that out on your picture, or if they're not numbers that were easy to graph, then just remember how we're finding those values. Now I also know from an ellipse that b squared is equal to a squared minus c squared. So b squared is equal to 6 squared minus 4 squared, so that's 36 minus 16, or b squared is equal to 20. The main thing is I have to remember which one goes under which one, and we already kind of set it up that way when I looked at which form that it takes. But remember, the bigger number is under the x when it's a horizontal major axis, and the bigger number is under the y when it's a vertical major axis. So I'm going to have my a is 6, so a squared is 36. And here I got that b squared is 20. So my equation is x plus 1 quantity squared over 36 plus y plus 1 quantity squared over 20 is equal to 1. Give us either the 2 foci, or maybe in another situation they gave us the 2 vertices, and we are asked to find then the equation. Now, when you have the eccentricity, remember they got the fraction for the eccentricity of c over a. But as we saw in a previous example that we did in this video, that if there are common factors between the c and the a, those would be reported in simplified form. So those common factors that might have existed between the numerator and denominator would have been removed. So I can't jump the gun and say that the top of my eccentricity is c and the bottom denominator of my eccentricity is a, because it might not be those values. You're looking at the simplified fraction, not the overall. So what I need to do is take that fraction they give me for the eccentricity and then look at whether I have c value or the a value and go through and solve for the other missing one. So right now I have that my eccentricity is 1/4, and I have that the foci, it's giving me the foci, are at -2, 4, and -2, -2. So with this being the x coordinate being the same, and if you just want to graph it out, because we can get turned around sometimes if we don't write the things out. So left 2, up 4, that's one of my foci. And left 2 down 2 is the other one. So my major axis is going vertical. Remember, your vertices and your foci are on your major axis. So since my major axis is vertical, I know it's x minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. That's what I'm ultimately getting to. Now, I also know that my center is the midpoint between these foci. So for my center, I can take the midpoint of the line segment connecting these 2 points. So average the x coordinates, -2 plus -2 over 2, and average the y coordinates, 4 plus -2 over 2. So for my center, I get -2 plus -2 is -4, divide by 2 is -2, which I expected it to be the same x coordinate because of it being a vertical major axis. And then 4 plus -2 is 2, divide by 2 is 1. So my center is -2, 1. That gives me an h value of -2 and a k value of 1. Your h always goes with your x, your k always goes with your y. Also, since my center is at -2, 1, the distance from my center to my focus is c. So notice that 4 minus 1 is 3, and 1 minus -2 is 3. So my c is 3. Yeah, not 1. It's not the top because this has been simplified. So my c is 3 from the information. You have to get it from there. Now that I know c and I know the eccentricity 1/4 is equal to c, which is 3, over a. Cross multiply, I get a is equal to 12. So a squared is equal to 144. And then lastly, I know in an ellipse that b squared is equal to a squared minus c squared. So my b squared is equal to 144 minus 9. So I get that b squared is equal to 135. And that gives me my equation of an ellipse. I'll simplify, minus a negative is a plus, but then we have our equation of our ellipse. So hopefully those 3 examples gave you kind of a stronger foundation that if you're given the equation, you can get the information about the ellipse, or if you're given the information about the ellipse, you can get the equation.